Today's topic is domain and range. If we have a graph of a function, f of x, as shown to the right, so this is f of x. That's nothing you've ever seen before. There's a piece that's a straight line, and then we have a curved piece that has a couple different turning points. A function can look like anything we want it to look like. So here's the deal. The domain are the possible x values. They're all the possible x values. While the range is the possible y values. If we look at the graph and we also look at those arrowheads, the arrowheads indicate that the graph is continuing in those directions forever and ever and ever and ever. We can conclude for the x values, all x values are possible since the graph extends to the left and right and keeps going forever and ever and ever and ever. When we're thinking about possible x values or possible y values, it may be useful to think about impossible values, things that can't be. And here, there's no such thing. Extends all the way to the left and all the way to the right. So there's no impossible values for x. So we say that x can be anything. Y, the vertical variable, is a different story. If we zoom in on the graph goes up and up and up and up and up forever and ever and ever and ever and ever. And yet, this is the lowest it ever gets. Well, how do I know that? Well, because over here, it's going up, 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 up to the left. So again, the lowest the graph ever gets is right here. That's an absolute truth. So if that's the lowest the graph can get, then that would be our minimum. So our range would be, otherwise known as the possible y values, anything equal to or above negative 6.2. And we're going to say that that value there is negative 6.2. Now, not all graphs continue forever. The second graph down below, it doesn't continue forever going up or down or left or right. We can see that there are absolute endpoints. So if we look at the left side, for example, we can see that the cutoff is right here at negative 4. That's the low end. The high end is at positive 4. So if we're talking about possible x values, it goes from negative 4 to 4. Anything in between that. It could be 0. It could be 1.2. It could be negative 3 7/8. Anything between negative 4 and 4 is fair game for x. Now for y, it's a little different. Not a lot different. It's a little the same because it starts at negative 4. But it doesn't go up to positive 4. Instead, it goes up to a maximum value of 8. So the possible y values would be anything in between negative 4 and 8. Now, as I said to my students in the morning, I often say, I speak 2 languages, English and math. Part of the math language is terminology like perpendicular, parallel, trapezoid, rhombus. There's also the syntax. And what do I mean by that? I mean what we write mathematically. Like, we remember when we wrote that 2 triangles were congruent, we would write triangle ABC, the equal sign with the squiggly on top is congruent to triangle DEF by side, angle, side, or whatever the heck. That's how we write things in a mathematical way. There's also a mathematical way to write domain and range. There's a hard way and an easy way. You need to know them both. When you are asked for the domain and range, you can give them to me in either way, but you need to be able to understand them if you get them in either way. Like, if I give you one in the hard way, you still need to be able to interpret that. So we're going to look at both ways of saying the domain and range. So this is the hard way of saying the domain, that x is between -4 and 4. So now I want to tell you something very important about all of this. First of all, it's very important to have these brackets. These are not square brackets. These are not round brackets. These are brace brackets. Brace brackets are used in mathematics to represent a set. The domain and range represent the set of the possible x or y values. So these are special brackets. You have to use these brackets when you use this way of writing the domain or range. Now, the domain represents the x values. So we start off by saying the domain is the set of x is. So that's why there's an x there. So you always have to start off with x. Then you have to write a vertical line like this. And that vertical line means such that. That vertical line means such that. And the rest is going to tell me or whoever else is reading your work what can x represent. Well, if we read this, it says x is less than or equal to 4 while being greater than or equal to -4. The important takeaway is that the signs are pointing in the same direction. And it's standard procedure to use this sign and have the higher number come second and the lower number come first. And that's about all there is to it. Okay? So if you're going to write the domain in set notation, it needs to look like this. Now, there's an easier way to write the domain. And it's a lot easier. You can also do it this way. This is called interval notation. You use square brackets to say that it can be exactly -4 and exactly 4, and you always write the lowest number first and the highest number second. So you just write square bracket -4, comma 4 square bracket. The first way we looked at it, again, is called set notation, and you have to be familiar with that. And the second way is called interval notation, and you have to be familiar with that as well. If you're asked to say what the domain or range is, you can pick either way. But you might be given a question where I give you the domain or range, and I might give it to you in either of those two ways, which is why it's important that you're familiar with both of those ways of writing the domain. Okay.
Wait, so
Here's the range in set notation. It is, because we see these brace brackets, the set of y values such that y is greater than or equal to -4, but less than or equal to 8. That's it. What would this be in interval notation? It's -4, 8. Now, I'm going to draw something else on here. Another graph. Try and find a little bit of room. Let's say we have something like this. And we are going to, I know, we'll do this one. There. And we want to write the domain. Well, that's kind of boring, but whatever. The domain and range are going to be the same here. Actually, yeah, I don't like that. I'm going to do this instead. I'm so sorry. Now the domain and range are not going to be the same. Okay? Now the domain and range are not going to be the same. They're going to be similar, but they won't be the same.
this is exactly what you did.
So the domain, if we were to write it out with set notation, it would be the set of x's such that x is greater than or equal to 0. That's what it would be in set notation. Interval notation is a little trickier. Why is it trickier? Well, what's its lowest value? What's the lowest value?
0.
0?
I mean,
Yes?
why? But it's going down.
Yes, but that's, if we're talking about x.
Oh,
What's the highest value?
0.
No. Highest value of x?
-1.
No. Highest value of x. What's the furthest the graph goes?
What kind of graph?
So, it's 0 to infinity. But when we use infinity, we cannot use a square bracket because there's no such number as infinity. Infinity is a concept, not a number. So we always use round brackets when we see infinity. Always. Always use round brackets when we use infinity. Now, let's talk about the range. For the range, it's a set of y values such that.
Hold on.
Now, for the range, it's going to be y is less than or equal to 0. So for interval notation, it's going to be negative infinity, round bracket, to 0, square bracket. And that's the range of that. Okay? Okay. So Maddie asked the question, can we have something that doesn't have a square bracket at 0? All right, let's do a question where okay, so there's a graph right there. There's a graph right there. Domain. Range. Let's just watch. Copies of the
Wait,
lesson.
we're doing another one?
Copies of this lesson will be available in print form and video form at some point this weekend. So, what's the domain here? Here's the deal. If you look at the domain, the smallest value this graph can be, and we'll just do interval form for this, by the way. Just keep it easy. Smallest value can be is not 0. It can't be 0. Because it'll get closer and closer and closer and closer and closer and closer and closer, but it never touches 0. So it goes from 0, round bracket, to positive infinity, because it never actually touches 0. And the range is the same thing. It gets closer and closer and closer to 0, but it never actually touches the x-axis, and it goes up to infinity.
Shouldn't it be infinity and then 0?
No, because it's always your lowest value to your highest value, and 0 is always less than infinity. So it has to actually equal the value. You have to see it actually equal the value to use square brackets. If it doesn't equal the value, then it has to be round brackets. This graph never touches 0. It never touches the x-axis or the y-axis. So that's why we have to use round brackets. And for some of the questions in your homework, you'll have to graph these functions using Desmos on your smartphones or what have you to see what the graph looks like, draw it, and then figure out what the domain and range is. Okay? So now, state the domain and range. I have, okay, we're going to do a couple more examples. Here we go. Now, we are given a set of ordered pairs like we would see in sets or functions, and we're asked to figure out the domain and the range. So the first value is always your x value. And we just finished saying that x is the domain. And the second value is y. And y is the range. But this is not a graph that connects a bunch of points. This is just a set of values. So your domain would be brace bracket, and we have to use a brace bracket because it's a set. We're going to write down all the x's. 0, 1, 2, 3. And then we write down the numbers that belong to the range, which are 3, 5, 8, and 12. That's it. We're just given a collection of 4 points. So there's 4 x values in our domain and 4 y values in the range. That's it. Part B is identical, except it's already divided for us because this is the x's and these are the y's. So if we're writing out the domain, brace bracket, just write down all those numbers in the first little bubble there. 0, 1, 2, 3, 4. And the range would be 1, 4, 6, 7.
Do you have to put them in order?
You do not have to put the numbers in order. So the numbers do not have to be put in order. It would be nice if they were in order. The interesting thing about this is, though, there's more stuff in the domain than there is in the range. That's not a bad thing. It's just a thing. Okay? All right.
Wait, do you have to put them in order from least to biggest?
Usually. Yeah, that's standard procedure. Okay? Last example, here we go. And this is like, let's apply this to the real life. For all those people that say, I want this math to apply to the real world. Here we go. A babysitting service charges $8 an hour to a maximum of $50, which equates to a daily rate. Complete the table of values below that have a certain number of hours, and it wants you to work out the cost. Okay? So, how much is 0 hours of babysitting going to cost you? Nothing. How much is half an hour going to cost you?
$4.
Yes. 1 hour. $8. $2 hours. 3 hours. 4 hours. 5 hours. 6 hours. 7 hours. Nope. What's 7 hours?
56.
Nope.
Isn't it 7 times 8?
Nope.
What? Why? Infinite.
Nope.
Shoot.
50.
Why?
Read the question. It says a maximum of $50.
Oh.
So,
So you got ripped off. That's what.
no.
Yeah.
No, and not ripped off. It's a maximum of $50. You got to read the question, right?
So then why
So-
would you work for over 6 and 6?
To give a bargain for people that want to put their kids there for the whole day. To attract more business. So, what's the domain? Now, this is interesting. If we're talking about daily rates, what do you think the maximum is somebody can babysit a child for in a day? 24 hours. So we would say 0 to 24 would be the domain.
You know how hard it is to babysit a kid 24 hours? I had to babysit a kid for a week straight. Like, I watched the kid 24 hours a day
That would be
for a
bad.
whole week.
Yeah.
I literally I've never wanted to just walk out on a child more.
I hear ya. What would the range be?
The range would be 0 to 50.
The range would be 0 to 50. All right, so here we go. We are going to do these examples right here. And so we're going to graph this. I will do you the honors of graphing these for you, but you may want to go about and do this with me. What you would type into Desmos is y equals negative 2x. And then you'd have to try and see what that looks like on Desmos. Now, so if we put 10 here, whenever we graph something, we do need to write down our scale. So the graph is going to look like this, this, and it's a nice straight line. And okay, so what you can see when you graph this on Desmos is it looks like this. So it goes all the way up to the left and all the way down to the right. You do have to keep, when you graph this on Desmos, you do have to pay attention to what the points are. And if you're at all unsure, you can always take your finger and touch the line or the graph and trace it along the line. And as you do that, it'll tell you values that are on the graph. But this is what y equals negative 2x looks like. You shouldn't need Desmos to draw this function. This function's a line. We just spent time graphing lines. This is not something you should need help with, although you can use Desmos if you need to. Now, when we see this, now we can go ahead and figure out the domain and the range. The domain will be, well, let's think about this. Is there any restriction on what x can be? No, because it keeps going to the left and it keeps going to the right. And the domain's about the x values. So the domain would be, in set notation, it would be the set of all x's such that x is an element of the real numbers. What does that mean? That means that x can be any real number. Just so you know, this is the Greek letter epsilon. That's the Greek letter epsilon right there. That is the Greek letter epsilon. And what it means is x is an element of the real numbers. We talked about real numbers in our numbers unit. We said that real numbers are basically every number we know. So x can be anything is what that means. If you want to write that in interval notation, you would write it as negative infinity to infinity, just like that. Both with round brackets, because infinity is not a number, it's merely a concept. The range is the exact same thing, except, of course, the range has to do with y. So it's the set of y's such that y is an element of the reals. And the interval notation is identical. It's negative infinity to infinity. Okay, so that's it for that question. Now we have 0.5x squared take away 4. So when we graph this on Desmos, I want you to do that, and I want you to tell me, because without spoiling it, it's going to look like this. But what I need to know is, and you're going to tap the point to tell me, what's this point, what's this point, and what's this point. When you type that into Desmos, and then you tap those points, it'll tell you the exact coordinates. So go ahead, type that into Desmos, tap those points, tell me what they are, and then we can graph that function.
Negative 2.828.
Okay, so that would be like about here, sure. And the right one?
The right and the middle one.
The right one.
2.8280.
And the middle?
And negative 4.
Yep. So it looks like this. This is a quadratic function. The grade 11s have spent lots of times with quadratic functions already this semester. You will too when you get to grade 11. Okay, now that we have our points, we can figure out what the domain and the range is. Okay, so now let's talk about the domain and range. Domain. What's the domain here? First of all, do we want to do set or interval?
Interval.
Okay, what's the domain then? Is there anything x can't be?
0.
No. Keeps on going to the left and to the right. So it'd be negative infinity to infinity. That's the domain.
So it can't be 0.
It can be 0, of course. It could be anything. Because it goes all the way to the left and it goes all the way to the right. So you're either looking for a spot where the graph stops or where there's a hole. The graph doesn't stop going left to right. There is a stopping point going up and down. So when we write the range, what's the range? What's the lowest the graph goes?
Negative infinity.
No, what's the lowest the graph goes?
Negative 10.
What's the lowest the graph goes?
Negative 4.
Negative 4, right? So we're going from negative 4, square brackets, because it can be negative 4, all the way to positive infinity, because it goes up and up and up and up and up and up and up forever and ever and ever. So that's the range, negative 4 to infinity.